Welcome to this month's FDTD Satellite Applications webinar. Today we're very happy to have Patrick Aid, the Science and Operations Officer from the Forecast Office in Duluth, talking about a convective application of synthetic aperture radar, SAR winds, over Lake Superior on September 5th, 2023. Patrick's been in the Weather Service for more than a dozen years. Before in Duluth, he was a forecaster in Bismarck. This is a part of an ongoing webinar series. The link is there on your screen. Dan Bikos and I are always looking for presenters. So if you have something you want to talk about, where you've used satellite imagery in the office for some kind of decision support or just something you noticed, let us know. We can help you get a presentation put together. Next slide, please. This will be about 20 minutes. Patrick will be speaking about 20 minutes. You can send questions via GoToChat or ask them during a Q&A period via the phone. This should be done by 1730 UTC. Please do not press hold. Mute yourself when not speaking. Take it away, Patrick.
All right, thank you, Scott. Thank you, Dan. Appreciate the invite. So, going to be going over one of our last severe weather events. Our severe weather season is rather short up here in the Northland, but this is from September 5th of 2023. So, utilizing some of these synthetic aperture radar or SAR winds over Lake Superior. Starting out with really an impressive picture of a shelf cloud taken about 30 or so nautical miles off the Apostle Islands. We'll show you where that is on the map, but again, Lake Superior, it is really an inland sea, not just a lake, really an inland sea. And this is taken by one of the first mates on the Dirk S. Van Enkenvoort, which is a tug barge, about 700 or so feet long, that is inbound into Duluth, and it's probably about 6 to 9 more hours left to go in its journey. But this was what was coming up at them, rolling off the north shore of Minnesota on September 5th of 2023. Just to give you a little bit of taste of what we deal with from a marine aspect up here at the Duluth office, we have convective responsibility for special marine warnings, and that's essentially gale gusts or higher, so 34 knots or greater gusts and penny size hail, things like that. But primarily our special marine warning mission is for the strong winds. We carry convective responsibility for the lake out to the western third. In more routine forecast operations, the open water is taken care of by Marquette, and we take care of those nearshore zones. But we also take care of 162 for severe weather, which dramatically increases the size of our convective warning area. On the left-hand side is a taste of our inland sea and how inhospitable, especially the North Shore, is. It's very rocky and there's not a lot of places to land, so it's a big part of our mission, especially for some of our smaller craft. It takes a long time to get off the lake to find a safe harbor, especially on the North Shore. And yes, even though our freighters are large, they're still very susceptible to strong wind gusts there. So you can see it's the lake at its best, and then the lake when it's getting a little bit more angry. Just a really quick rundown of just the setup, I guess a usual slight risk for us. We saw day 3 marginal, almost a near perfect circle across portions of the upper Midwest. And then that became what was a little bit larger slight risk across our region as we moved into the day 1 outlook. Nothing, no one threat being overly significant as we're kind of moving towards the later portions of our severe weather season up here in the Northland. Just to give you kind of a setup, we won't spend a whole lot in the mesoscale analysis or the environment, but here's the mid-level water vapor loop, fairly long loop that takes you from around the late morning and into the early evening on September 5th. And we see what is a rather impressive elevated mixed layer aloft, those deep oranges and cyans that are working their way up from the Intermountain West into our CWA up here on the western edge of Lake Superior. So really providing us with a plume really steep mid-level lapse rates that are going to play into some of the wind potential, especially for this event, and how the SAR winds came into that. Just a kind of a corresponding loop of the max 2 to 6 kilometer lapse rates and the D Cape. We see, well, as you would expect with that very significant elevated mixed layer, very steep mid-level lapse rates. Again, I kind of like that 2 to 6 kilometer max lapse rate instead of just the mid-level lapse rate in SPC, because it's not just tied to 7 to 500 millibars. It really tries to find the steepest lapse rate in that layer. And what do you know, D Cape's very high as well, so well above 1,000 and pushing almost to 1,500 joules per kilogram across northeast Minnesota, northwest Wisconsin, and then across Lake Superior. One other thing we were watching that day is also the all-layer precipitable water, and seeing that, well, you can see where the elevated mixed layer was essentially punching in, where there's a little bit of minima in the ALPW, but we see ahead of that being invected in and drawn into it, very deep Gulf moisture that's evident on all the layers, from the surface 850 millibar layer all the ways up into the mid to upper level layers of the atmosphere. It's a very deep moisture working its way in all the way from the Gulf, and not just low level moisture working in ahead of it, but also very deep moisture through the mid to upper level portions as well. So here's about a 90-minute radar loop, and what's going to happen is that this line of convection is going to eventually run over the Dirk S. Van Enkenvoort. So the Apostle Islands, you can see them there just off of Bayfield, very beautiful, picturesque place. And the Dirk S. Van Enkenvoort is about 30 nautical miles off to the northeast. We'll put a dot on them on the next slide or two. But what we see is in about that hour and a half that's really leading up to when they were impacted by the strong winds, is that we see convections congealing. It's definitely organizing into a linear structure with a very tight reflectivity gradient on the leading edge. We see the cold pools balance, and we're not seeing a whole lot of outflow racing out ahead of the convection, at least over the lake. So we're favoring a fairly, favoring the longevity of this system, and really an organized and potentially strengthening cold pool to really help drive those potentially strong winds down to the surface and even the surface of the lake. This is always a challenge for us. Is Lake Superior is the coldest of the Great Lakes, and it is always a challenge of how stable or unstable the boundary layer is. Being in late summer now, this is we're really now transitioning more towards the unstable season, where the lake temperatures have warmed up enough such that even if it's more summer-like out, we can still get momentum to the surface. And then when, well, now it's turning to fall up here, and we get really steep lapse rates because the lake is just so much warmer than the air. So again, it's not balmy. It's the water temps are in the 60s, but still, relatively speaking, that's pretty warm for us up here to really help drive some momentum transfer. So there it is. That's the Dirk S. Van Enkenvoort. And what it is the Dirk S. Van Enkenvoort is actually the tug. So, and so this isn't your typical lake freighter. It is essentially a tug attached to a barge, and a lot of these barges are old freighters, old lakers that have been chopped up a bit, and now it's more of a tug barge system, so that the barge is about 700 or so feet, and the tug itself, about 100 or so feet. So you got about a 700 to 800 foot vessel. These have a little bit more susceptible to stronger winds compared to some of the other types of vessels that do traverse the Great Lakes. But what we saw on this was between 6:15 and 6:25 p.m. A peak gust, and you can see it there on the right, to 61 knots recorded on the pilot house. And of course, the pilot house is elevated, and on the right-hand side, you can definitely see the view of what that shelf cloud looked like. But that convection was walking right along with that really steep D-Cape gradient, right? And our water temps were in the mid-60s. So for us, relatively speaking, we've kind of have really weakened kind of that stronghold that it has on the boundary layer. And the challenge, especially for us from a warning perspective, was velocity was not overly impressive, but using the rule of 2 out of 3, trying to incorporate reports on the environment into that. So we'll take a deeper dive into it. There's where it was. So about 30 or so nautical miles off of the Apostle Islands inbound in. And again, peak gust to 61 knots. We're unique here at Duluth because we do have Ron Williams, who is our port meteorological officer, really helps to run the voluntary observing ship program up here, not only at Duluth, but also for the entire Great Lakes. And he has his colleagues that also do the same job. You may have heard the acronym PMO, Port Meteorological Officer, also for really all of our ocean offices as well. And so he's got really great relationships with a lot of, all the, especially the American and Canadian ships that are on the Great Lakes. And are the images that are coming into his phone from the first mate. And then he's really been a big help at relaying those into our own operations, because there's not many observations on Lake Superior, and we'll get into that. So here's where we finally get to, and that is the synthetic aperture radar, or SAR. I see only an SA up there, but that's okay. So I went and there was a very timely pass from Sentinel-1 of the convection, where we saw widespread 30 to 45 plus knot gusts. You will see some higher values in there, and we'll take a deeper dive into it. Talking with Chris Jackson, one of the experts, that some of those really higher values might be somewhat erroneous due to some scattering effects from probably just the abundance of ice crystals within the convection. But boy, this gives us a really tremendous view in a very data sparse area of what the potential winds are, to really kind of validate our own conceptual models, verify warnings, and help us to, if we have the trend now, we can extrapolate that downstream. So what is SAR? Well, SAR is synthetic aperture radar, and basically what that does is that it maps the microwave radar reflectivity of the surface, and depending on the bands being used, and depends on how much scattering, backscattering you're going to have, related to roughness as well. So for these side scanning SARs, that radar cross section is proportional to surface roughness, which is going to be our key ingredient of how we back out wind measurements from SAR. Well, what's synthetic about it? And all these points, big thanks to NESDIS and NASA for their resources on this. It's synthetic because if we want the high resolution imagery, well, that resolution is proportional to that ratio of sensor wavelength and the sensor antenna. So if you want really high resolution data, you need a giant antenna, which is just not feasible in space, right? So what they do is using synthetic aperture, which is basically using a sequence of these acquisitions to be able to simulate imagery that you would get from a much larger antenna. Okay. So radar and these microwave systems have the advantage of that they're all weather. So we can see through the clouds, which is, I'll show a little bit later, some winter application as well as a bonus, but we are able to back out the winds from the roughness from that back scattering. In order to kind of launch that, converting that normalized radar cross section roughness to a wind speed, to kick that off, we need direction, which is provided for within the SAR imagery by the GFS. And we can get these wind retrievals to 500 meter resolution. So this is a major win, especially for us in a very data sparse region. You can see there what I have plotted up is from the National Data Buoy Center. All those diamonds are marine applications, some of them land-based, some of them are buoys, but there's not many of them. We do have supplemental observations from our ships, which we're so very grateful for. But this really is able to fill in major data gaps in our area, to really provide us really high resolution imagery to confirm our own conceptual models or our own warning methodologies. The challenges, though, are that it is a polar orbiter, and that the number of passes is limited. So for consistent application in near real-time ops, it's a challenge. No news there, nothing new there, right, with Polar, but we get about 2 passes a day over Lake Superior around 12Z and around 0Z. They don't cover the full part of the lake. Sometimes you get big chunks of the lake, sometimes you don't get small chunks, just depending on where exactly the satellite is tracking. Some other challenges, and this is again a credit to Chris Jackson, is some of those higher values, approaching probably 50 plus knots, are probably somewhat erroneous due to some of the scattering from just the large amount of ice crystals within the convection. These SAR wind retrievals are not valid over land. They are not valid over sheets of ice, which we'll talk about also as well. And one thing also that comes to mind is, especially for these these applications, especially for convection or just the high resolution nature that we're seeing, or this data at, is the GFS the best way to kick that wind calculation off, or should be the HER or something else with maybe a little bit more resolution, maybe some more convective, allowing to see some of these interactions with the cold pools, and how would that potentially impact some of the wind retrievals if, say, a CAM was used instead of a global model. Thanks to Scott Lindstrom, who I sent him an image of, hey, this is what we saw the other night, and turned it into a really outstanding sim satellite blog post, and there is the link there. And like I talked about, it's not just for winds. The synthetic aperture radar has had great utility for us for ice monitoring. And so what we see here is a loop from late February of 2023. And what we see is ice that's being blown down the lake in strong northeast winds. And what we eventually see is what looks like stratocumulus at the head of the lake here off the Twin Ports is really a bunch of ice buildup. And we utilize this normalized radar cross-section for ice monitoring a ton here in Duluth during the winter, to monitor how is the ice moving, what is the characteristics of the ice, obviously concentration, and then are we going to start closing down some of our forecast zones. And in this case, we're really looking to see how ice was being infected down the lake. It was a relatively low ice year, but we did have some areas of ice that were easily becoming mobile, and we wanted to see how those would be, if they would pile up at the end of the lake, because in prolonged gales, we can get lakeshore flooding just with some little bit of SAISH added on to high waves. And what we're able to do is really, instead of issuing upgrading our lakeshore flood watch to a warning, we didn't upgrade at all because we saw the ice piling up at the end of the lake. And this is what it looks like right off Minnesota Point at the head of the lake. All that ice infected down, built up a wall, and the really significant waves from the gale, well, all that energy was dissipated before shore. And there was no flooding. There was really no wave action even getting to shore. And so this is a great application of SAR data in the normalized radar cross-section and ice monitoring, and helping that operational impact to not issue a warning, which is just as important of a decision as to issue a warning. Plug in for the NES's Great Lakes SAR page. There it is. Again, this for us is just a tool that's utilized very heavily in the winter, and then also we're able to apply it to a summertime case. So if you have any questions, there's my email. Again, there's that last image off the Dirk S. Van Enkenvoort as that shelf cloud is approaching, which was pretty much very well timed with that SAR pass to give us really a amazing look at the wind structures associated with this evolving wind threat as it crossed the lake. Again, able to verify our conceptual models of that inform our warning strategies, able to potentially be used as verification, and then how do we utilize this data to be able to really inform more research on the road, or the things in here that we're seeing that we may not have thought about from a convective wind interaction with the lake. So with that, I will open it up to any questions.
Great. Thanks a lot. I think I've just put the link to the Great Lakes SAR data into the chat. I think I sent it to everybody. But I just want to make a comment that the satellites have a repeat cycle of 12 days. So maybe it's difficult to remember where it was 12 days ago, but you're going to get the same view you got today that you got back on the 22nd of September. So that's one way to, put a little alert out on your phone or your computer to say, oh, there's SAR data now because we had it 12 days ago. So that's just something that you can do if you're interested in looking at this. So I don't see any questions, I don't think. Okay. I do see a question. Let me see if I can. And I think I can unmute you, Tyler. So let me see what I can do. Let's see, unmute. Tyler, you
hello.
should be unmuted. Go ahead.
Okay. Sorry, it said it was disabled. Thank you, Patrick, for that great talk. My name's Tyler Ruff. I'm a close colleague with Chris Jackson, who wasn't able to make it today, but you referenced him a lot in this talk. So I just wanted to mention about the SAR wind imagery, the one that you have up there right now. You mentioned that we think that some of these returns are due to ice scattering in the atmosphere. What we believe is that the leading edge of this dust front is correct in the SAR. So that's correct. Everything maybe like 50 knots to 60 knots, kind of like the dark red color, I would say that's an atmospheric effect. It's a little tricky to sort of differentiate between the two when they're kind of overlapping. Right. Yeah, exactly. So in these copole wind retrievals from the SAR, we typically only believe them up to about like 40, 45 knots. So you basically described it accurately. I just wanted to mention, yes, we believe the leading edge retrievals, but maybe not the trailing ones in this situation. But personally, I'm just delighted that you're using our new SAR Great Lakes webpage. We always love it when the forecast offices tell us this, and we can work directly with you guys. And if you have any additional needs, please let us know. We're always here to try to help you and improve our own products.
Excellent. Thank you, Tyler. Really appreciate that. And I appreciate, again, your expertise on, being especially from a student and operational perspective, we try to get a handle on synthetic aperture radar, right, and trying to become as much of at least a functional expert as I can in this, and then being able to have you guys back us up and confirm what we're seeing. So I appreciate that, because it's those dark high values really pop out to your eyes, but it's good to know to place them potentially in context with the kind of the limitations of the instrument.
Thanks, Tyler. I also see a comment here from Kevin at the Duluth office about the ability of SAR to penetrate clouds. Just a reminder that this is actually a function of wavelength, not SAR. So I suppose there could be SAR data at different wavelengths that would be unable to penetrate clouds, but the ones that are on the radar constellation mission and RadarSat and Sentinel, that SAR imagery, that SAR data, those SAR wavelengths are able to penetrate clouds. So just something to keep in mind. You see, I don't see any other questions. And unless we don't have any, I'll give you 5 seconds to put something in, or you can raise your hand. Otherwise, I'm going to thank Patrick for the presentation today. I always like seeing stuff in the Great Lakes and SAR data. It's very compelling imagery to look at for both wind and for ice, now that we're getting into the less desirable part of the year, in my opinion. So that's it for today. Thanks for the attendance to everybody, and we'll see you next time.